My dear students, in the previous video, I have explained some theorems on independent events. Now, and in this video, I am going to solve some problems using that theorems. The two events A and B are such that the two events are given such that probability of A is 1 by 2 and probability of B is 7 by 12. And probability of probability of not A or not B. Probability of not A means A dash. Probability of not B means B dash. Probability of not A or not B means P of A dash intersection B dash. Sorry, or P of A dash union B dash is 1 by 4 given. State whether A and B are independent. That is the problem. See, you know that probability of not A or not B means probability of not A is A dash, not B is B dash, or conjunction or is union. Suppose here P of not A and not B, if you have, that is P of A dash intersection B dash. In this, if you instead of or, you can find and. P of not A and not B means P of A dash intersection B dash. In the case of P of not A or not B means P of A dash union B dash. That is given by 1 by 4 probability. Probability of A dash union B dash is equal to, by the De Morgan's law, probability of A dash union B dash is probability of A intersection B whole dash, by De Morgan's law. This is nothing but total probability 1 minus P of A intersection B. P of A dash is 1 minus P of A, you know. Therefore, P of A dash, probability of A intersection B dash, B whole dash is 1 minus probability of A intersection B. This is P of A dash union B dash is given by 1 by 4. P of not A or not B is 1 by 4 equal to 1 minus P of A intersection B. So, probability of A intersection B equal to 1 minus 1 by 4. From this expression, I get probability of A union B equal to 1 minus 1 by 4. That is equal to 3 by 4. So, if A and B are independent, we know that P of A intersection B equal to P of A into P of B. P of A intersection B we derived with 3 by 4. It is equal to P of A 1 by 2 into 7 by 12. That is 7 by 24. 3 by 4 equal to 7 by 24, which is not true. That means A and B are not independent. That's all about the problem. Okay? So the next problem. See, I am solving the problems in the 12th standard CBSE textbook. That is in the exercise 13.2, I am solving these problems. So the previous problem is in your CBSE 12th standard textbook, in the exercise 13.2, 10th problem I have solved. So in the textbook it is in the given as 14th problem. That is, the problem is probability of solving a problem by A and B. Two individuals A and B are given by 1 by 2 and 1 by 3 respectively. A problem solving by the two individuals A and B are given as 1 by 2 and 1 by 3 respectively. If both try to solve the problem independently, find the probability that the problem is solved. First case. And second one is exactly one of them solves the problem. The first case, probability for solving A. Probability for A solving the problem is P of A 1 by 2 given. Therefore, probability of A not solving the problem is P of A dash. Probability of A solving the problem is 1 by 2. And the probability of A not solving the problem is P of A dash. That is 1 minus P of A. Complement event of A. That is 1 minus 1 by 2 is 1 by 2. So, probability for A not solving the problem also 1 by 2. P of A dash. Similarly, P of B, probability for B solving the problem is 1 by 3. That is, P of B is 1 by 3. So, probability for B not solving the problem is P of B dash. Probability of B dash is 1 minus 1 by 3. Complement of the event B is 1 minus 1 by 3 is 2 by 3. So, from these two things, first we have to find out the probability the problem is solved. Find the probability that the problem is solved. That is, the problem is solved means 1 minus problem not solved. The total probability 1 to be subtracted. From that 1, we have to subtract it for the probability for problem not solved. So 1 minus probability for the problem not solved is probability of A dash intersection B dash. A dash is A not solving the problem and B dash is B not solving the problem. So problem is not solved by both A and B is probability of A dash intersection B dash. Okay. So since A dash and B dash are independent events, 1 minus P of A dash intersection B dash is P of A dash into P of B dash, because A dash and B dash are independent. Therefore, P of A dash is 1 by 2 and P of B dash is 2 by 3. Simplification, you get, what is that? 2 cancel. 1 minus 1 by 3, that is equal to 2 by 3. Therefore, the probability for the problem is solved is 2 by 3. Okay? The second subdivision is probability for exactly one of them solves the problem. That is exactly one of them solves the problem. Probability for exactly one of them solves the problem is, if A solves the problem, B is not solved the problem. B is not solving. Or if B solves the problem, A not solving the problem. This is the condition. If exactly one of them solves the problem is P of A into P of B dash plus P of B into P of A dash. If A solves that problem, B does not solve. If B solves the problem, A does not solve. So this is exactly one of them solves. This case is this. Probability of A, you know, 1 by 2. Probability of B dash is 2 by 3. Plus probability of B is 1 by 3. And probability of A dash is also 1 by 2. So this is equal to 2 by 6 plus 1 by 6. 2 by 6. This is 1 into 2, 2 by 6 plus 1 into 1, 1 by 6. That is equal to 3 by 6. That is equal to 1 by 2. So the probability for the exactly one of them solves the problem is, if A solves, B does not solve. If B solves, A does not solve. In this case, P of A is 1 by 2, P of B dash is 2 by 3. Similarly, plus P of B is 1 by 3 and P of A dash is 1 by 2. So this is 2 by 6 plus 1 by 6, that is 3 by 6, that is 1 by 2 is the probability, required probability. Okay? So next problem in your textbook, problem number 16, it states that in a hostel, 60% girls read Hindi newspaper and 40% girls read English newspaper, and 20% read both Hindi and English newspapers. A student selected at random, find the probability that she reads neither English nor Hindi. That is, yes, hostel consisting of the students, that is 60% girls reads Hindi. That is probability of Hindi read girls, probability of H means Hindi. Probability of Hindi reading girls is 60%, that is 60 by 100. Probability of English reading girls, P of E is equal to 40%, therefore 40 by 100. Both English and Hindi reading girls is 20%, that is P of H intersection E. Hindi and English reading girls 20%. So you know that probability of Hindi reading is 60 by 100, and complement event, probability of Hindi not reading girls, probability of H dash is 1 minus 60 by 100, that is 40 by 100. H is 60 by 100, H dash is 1 minus 60 by 100. Probability of not reading Hindi girls is 1 minus 60 by 100, that is equal to 40 by 100. Similarly, probability of not reading English girls is, probability of not reading English is 1 minus 40 by 100, that is 60 by 100. We want the first case, find the probability that the girl neither reading English nor read Hindi, neither Hindi nor English reading girl. Probability for finding the girl reads neither Hindi nor English, that is probability of neither Hindi H dash nor English H dash, P of H dash in neither English nor Hindi. P of H dash intersection E dash we want. First question is our idea. Find the probability that she reads neither English nor Hindi. That is H dash intersection E dash. Neither Hindi nor English. P of H dash intersection E dash. That is equal to, this is probability of H union E. Probability of probability of H union E whole dash. Probability of H dash intersection E dash we want. That is by De Morgan law, P of H dash intersection E dash is equal to P of H union E the whole dash. That is equal to 1 minus P of H union E. See, we have to find out P of H union E. We know that probability of H union E equal to, by formula, P of H plus P of E minus P of H intersection E. So P of H, 60 by 100 plus P of E, 40 by 100 minus P of H intersection E is 20 by 100. This is 60 plus 40, 100 minus 20, 80 by 100. So P of H union E, P of H union E equal to 100, LCM, common LCM 100, 60 plus 40, 100 minus 20, 80 by 100. So this is P of H union E. So what do you want? We want the probability for a student reads neither Hindi nor English. Neither Hindi nor English. P of H dash intersection E dash equal to 1 minus P of H union E. That is the result. P of H union E. That is equal to 1 minus P of H union E is 80 by 100. So this is 100 minus 80, 20 by 100. That is equal to 1 by 5. Therefore, probability for a student reads neither Hindi nor English is 1 by 5. That's all. Okay? So the next subdivision, B subdivision in the problem, find the probability of the girl that she reads English if she reads Hindi. Find the probability that she reads English if she reads Hindi. That is P of E under the condition. The even H is already occurred. Find the probability that the girl reads English if she reads Hindi. P of E by H we want. P of E by H is P of E intersection H by P of H. That is our problem. You know P of E intersection H. P of E intersection H. These H and both are the same. E intersection H is 20 by 100 by P of H 60 by 100. That is equal to 20 by 60. That is equal to 1 by 3. So find the probability that she reads English if she reads Hindi. P of E by H is equal to P of E intersection H by P of H is 1 by 3. Similarly, the C, third subdivision is find the probability that she reads Hindi. Find the probability that she reads Hindi, if she reads English, if she reads English, that is the next question. So find the probability that she reads Hindi if she reads English already. P of h by e. Third subdivision. Find the probability that she reads Hindi if she reads English. That is equal to here again P of h intersection E by P of E. P of h intersection E 20 by 100 by P of E 40 by 100. That is equal to 20 by 40. That is equal to 1 by 2. So that's all about the problem. I will stop the video here. We will continue the remaining problems in the next video. Thank you.